In this video, we're going to talk about the geometric series and the test for convergence or divergence, okay? And so the geometric series, we usually will see some number an. This is general form, it's an is equal to a1 times q raised to the n minus 1. Now, some books and stuff like that, I'm pretty sure your book probably uses r, but again, it doesn't matter. Q or r, the variables doesn't matter, okay? But I just wanted to throw that out there, okay? And in a series fashion, it's usually given as a partial sum of a times q raised to the n minus 1. And we say if the absolute value of q is actually less than, the absolute value of q is strictly less than 1, then the series converges. Okay, now if the absolute value of q is actually greater than or equal to 1, so the absolute value of this number is actually greater than or equal to 1, then we'll say the series diverges. Okay, now to find its sum, which is exactly what the series converges to, well, we say the sum is equal to a1 over 1 minus q. Okay, again, in some books you will see the sum is equal to a1 over 1 minus r. I don't know why I write r1 right there, but that's just r over 1 minus r. Okay, and so that being said, let's look at a couple examples to kind of test our idea. So what if I ask you to determine whether the series converges? So what if I ask you to determine convergence and find its sum? Well, let's look at this one. We have the series where k from k is equal to 0 to infinity of 1 over 2 raised to the k power. Okay. Well, does this series converge or diverge? Well, it looks to me is that my absolute value of q is actually less than. So my absolute value of q is actually less than 1. Well, what is my q? My q happens to be 1/2. So we know 1/2 is actually, the absolute value of 1/2 is actually less than 1. So therefore we could conclude that the series actually converge. Now, what does it converge to? Well, in order to do that, we got to find its sum. Okay, so we know the series converges. Okay, so what is its sum? Well, the sum is equal to a1 over 1 minus q. Well, we know what q is. It's 1/2. Well, what is a1? Well, since we start at 0, our first term has to be where we plug in 0. And so if we plug in 0 in for k, well, 2 to the 0 power is 1. Okay, and so that means that in this case, the first term is actually 1, because 1 divided by 1 is 1. Okay, and then this is 1 minus q, which is just 1/2. Okay, if I simplify a little bit more, this just becomes 1 over 1/2. And that being said, we just multiply, which is going to be equal to 2. So therefore, the series actually converges to 2. Okay, so again, this is a simple math. The only thing I did is just simplify. So this becomes 1/2. So 1 minus 1/2 is just 1/2. And then we divide 1 by 1/2. That is 2. Okay, so that's how we find how the series converges and how we find the sum, or where to actually what it converges to. So what about this one? This is where from k is equal to 0 to infinity of 5 over 4 raised to the k power. Okay, what if we had to determine whether this series converges or diverges and find its sum? Well, to me, it looks as if you gotta be very careful here. Be very careful here, okay? Well, to me, well, what is my q? Well, my numerator is a constant, okay? My numerator is constant, and so in fact, I could actually rewrite this as, if I pull my 5 out, this is 5 times series from where k is equal to 0 to infinity of 1 over 4 raised to the k power. Okay, so we got to be very careful. We got to be very careful. And so if I look at this from this way, well, in this case, I know my q, which is 1/4. The absolute value of q is actually less than 1. So we know our series converges. So our series converges. And in this case, we know our q now happens to be 1/4. The absolute 1/4 is less than 1. So our series converges. Okay. Now, what is its sum? Well, the sum is actually a1, the first term, sorry about that, over 1 minus q. And so if I look at this, well, my first term, if I plug in 0, because this is where my series starts from. Well, if I plug in 0, hopefully it's very evident that if I plug in 0, well, 4 raised to the 0 power is 1. 1 divided by 1 is 1. And we have this 5 outside here. So 5 times 1 is actually 5. So the first term is 5. We subtract and we divide that by 1 minus q, which happens to be 1/4. Okay. Well, hopefully you know by now is that 5 divided by 1 minus 1/4 is just 3/4. Okay. And so if we multiply, this becomes 20 over 3. So the series actually converges to 20 over 3. Okay. So this is how we look at geometric series, okay, and be very careful. This one, the first term, q was not 5/4, okay, so be very careful.